All right, so this is just the basic thing that we looked at yesterday. For this activity, we got to remember that f of x equals a sine b times x plus c in parentheses plus d. Amplitude is a. I really should put some absolute value bars around there. Period is 2 pi over b. Phase shift is negative c over b. Midline is y equals d. Okay, so that's that same thing from the notes that we looked at yesterday. So this slide is just there to remind you of those things. You can flip back to it while we work on these. We got a student view, so. All right, so I want you to write the equation of this graph. Now, one thing you may, because we haven't done a lot of these, you may be a little bit unsure of, is whether to use a sine or a cosine graph. Okay. It is always true that you can do either. Okay. Because sine graphs and cosine graphs look exactly the same. If we want to turn a sine graph into a cosine graph, all we've got to do is slide it over. All right. But sometimes it's easier to do one than the other. So that sine graph that we had, its y-intercept was at the midline. And then it goes 1, 0, negative 1, 0. So the original sine graph looks like this. Cosine is going to have a y-intercept at a maximum point. Like so. Cosine originally looks like this. So a lot of times there's graphs that are easier to do one than the other for. Which one would be easier for this one? Sine, because you don't have to shift it left or right. So sine is going to be the easiest for this one. So go ahead and type in your equation for this graph. Do me a favor when you type it in. At the beginning, you either need to put like a y equals or f of x equals. Because it's technically not an equation unless it has that y equals or f of x equals. Or g of x or z of x, whatever you want to call it. All right, so make sure you've got yours typed in. All right, so do me a favor, do not change your answer as I'm talking right now, because there are a lot of things, some of you have things that are wrong, but there's a lot of valuable things for us to learn from those wrong answers. So you have a different name. I'm not going to tell anybody who you are. So whenever I fuss at Tabitha for having something wrong, nobody knows you're Tabitha, so you don't have to worry about that. And we can learn something a lot of times from these wrong answers. So don't change it right now, but then once I've talked about it, we'll all change it to the correct answer. So let me show you what the results look like here. And it wouldn't hurt if I zoomed in just a hair. All right, and got rid of that stuff I was drawing over there. So we agreed that sine would be the easiest for this one. So sine would be the easiest for this one. So it looks like everybody did that, and it looks like everybody has a 3 out front as their amplitude. So that's wonderful. You definitely need the 3. Where we have a lot of variation is over here for what is inside of our sine function. So we've got pi over 2, we've got a pi, we've got pi times x. We just have an x, we got 2 pi. So we don't have very much repeat. We got a few people with sine that's blank. We can't leave sine blank there. So that would not be right either. So we've got a lot of variation on that. So this number that's multiplied by your variable, you need an x or a theta there, whatever you want to use for your variable. That variable there, you must have a variable. So any of these without a variable are going to be wrong, because sine of pi over 2 is 1. It's always 1. So if I graph y equals 3 sine pi over 2, it's just going to be a horizontal line. So you have to have a variable. So, for example, John, I'm pretty sure that's Jaime Escalante. I think that's the guy from the movie that I show in calculus sometimes. He wasn't really like a mathematician. He was a teacher. Sarah would be, and I'm not saying Sarah's right, but Sarah would be okay, because Sarah does have a pi there, but also an x. Ada has a variable. Margaret does not have a variable. Pi is technically a variable, but it represents a constant number, so that would not work. Erica doesn't have a variable. Abraham's okay. Brittany's okay. Audrey's okay. Annie's missing something. Sylvia does not have a variable. David does have a variable, so he would be okay as far as graphing this. So you must have a variable there. Now let's talk about what we need with that variable, or if we even need anything with it. So that B number, the number in front of your variable, helps you determine your period of your graph. Okay? So let's think about this graph that we've got right here. What is the period of this graph? It is 2 pi. Okay? How do we get that? I like to always start at 0 right here, just because it's easier to count it. Although I'll show you another way you can look at it as well, right? So we would go up, back down. Right here at pi, you are back to where you started from, but you haven't done the negative part of this graph yet. So you haven't started to repeat yet. So we go back up, and then we would hit over here. I can't see what that is because I ran out of room. But if I look over here at the other side, I can see that I had negative 2 pi there. So this is going to be 2 pi over here. So you start to repeat after you get to 2 pi. So the period of this graph is 2 pi. Okay. However, 2 pi is not what we put into the equation, because for this, to find the period, we do 2 pi divided by the b value, where we've got y equals a sine bx plus c plus d, right? So we got to do 2 pi divided by that b. Well, for us to get a period of 2 pi, we didn't divide it by anything. We just divided by 1, right? So, so that b value, the number in front of the x, needs to just be a 1, which means it's just going to look like what Ada here has, f of x equals 3 sine x. Okay, so this is really important. A lot of students mess up because they just take the number they get for their period and they put it there with the x. That does not happen. So for this one, we should just have f of x equals 3 sine x for this one. So if you do not have f of x equals 3 sine x, you can go ahead and change it now. That, because you can pull this back up if you need to look at it. This is sort of like our notes for today, so that way you'll have the right. I'd like for you guys to have the right answers in so you can look back at it if you would like. So if the period of one of these graphs is 2 pi, the period has not changed. So we don't need to put any numbers there for our b value. Does that make sense? We did very good on our amplitude. That one is one of the easier ones to find. Nobody put like a +7 over at the end, which is good because you're not moving this up or down any. And we didn't do any shifting left or right. Now, it is possible. I'm going to show you another one that you could put just for fun right here. So, cosine graphs, if I had, let me use a different color. If I had y equals 3 cosine of x, it would look almost like this, but instead of having y-intercept at the midline, it had y-intercept at the maximum point. So it would look originally like this if I had that cosine graph, right? Like I'd have this. That, of course, is not the red graph we're looking for. But we could turn this into that red graph just by shifting it. So if I wanted to shift this over to the right, pi over 2, then I could make this x minus pi over 2 inside of the parentheses, and that would shift this whole graph over pi over 2 to where it matches the red graph. So another option for this would also be y equals 3 cosine of x minus pi over 2. It's not the easier option. If I'm asking you to name something for this, it's much easier to use sine, but it could be done with cosine as well. All right, let's go to the next one. Student view again. Let me get rid of all my scribbling. Okay. I haven't gone to the next one yet, have I? All right. Here is our next one. New graph. Write the equation for this graph. Again, sine or cosine doesn't matter, but there might be one that's easier than the other here. And again, on all of these, you want to put a y equals or f of x equals at the beginning. And I'll record the rest of this, Connor, and the homework will be another Desmos classroom that's posted there. It should have a link. I checked it, and I think it should work. You're welcome. Okay, let's look at what we've got here. So if you guys will leave what you've got for a minute, and then we'll change it to the right thing, because sometimes we can learn a lot from what we may have incorrect. So we've got, I think everybody used cosine this time. That was a smart choice because your y-intercept is at a maximum point. So you don't have to shift this one left or right if you use cosine. So that is a good place to start. And then a lot of these have a -1 on the end. I didn't get that. A few do not. But that -1, what that does is it shifts the graph down 1, which would make the midline of this graph be at -1, which does look like that line that goes through the middle of this graph. So you do need that -1 on the end. And then, let's see, Most of us have an amplitude of 2. A few of you are not missing or do not have that. There is an 8 right there, and then a couple without one. But our amplitude, like Talitha here has an amplitude of 1. And it's possible that, I'm not sure, and I don't want to call out Talitha here, but Talitha right here may have looked at that highest point and thought, well, that amplitude is 1 because that's the highest that it goes. That will be the case, like on the last problem, if the graph has not been shifted up or down. But this particular graph has a midline at -1. So you're looking at the distance from the midline up to that highest point. So that is 2 for this one. We did pretty well on that one. This f of x equals 2 cosine x minus 1 would be the correct graph here. So if you do not have that, you can go ahead and change that to make that match. It does not change anything. If you do not put parentheses, so like Jaime here has not put parentheses, and Sarah, well, no, Ada does have them. It does not matter. Because if you don't put parentheses, it is assumed that only whatever is right after the sign goes with it. So if I see this one right here, it would be assumed that only that x is inside of the parentheses. In order for that -1 to be on the inside of the parentheses, you would have to have a set of parentheses there. So you can write it either way, just whichever way works best for you. But it would be incorrect if that -1 is inside of the parentheses, because then that would shift it left or right. But you can put it on there or leave it off. Okay, questions? Let's see. Let's get rid of that. Let's go on. All right, here's a new one. Try this one. Oh, also, this is unrelated, but I'm not sure if it was at the beginning of announcements. I don't know if we heard it. Prom tickets go on sale Monday, starting Monday. They're cheaper if you buy them the first 2 weeks. They're $15 each. So if you're going to get prom tickets, they'll be selling them in the front office. You can get those there. If you have an outside date, that form is due April 28th, and you have to get, like their principal, I think, to sign it, or an employer. So you can't wait till April 27th very easily to get that filled out. So if you have an outside date, make sure you get that form in, because those are due very shortly. It will be here before you know it. Tell your friends also, because I know there's really no excuse. They email out announcements every day. We listen to announcements. They've got it everywhere, but I know that still sometimes students ignore all of that. This one's a little trickier. We're getting a lot of different answers on this one. All right, let's see what we've got. So please don't change it for a minute, and then I'll let you change it back in a second. So let's see, first of all, whether we chose sine or cosine. Most of us chose cosine. I do have a couple. Abraham chose sine. but did shift it. So that could possibly work. Sylvia chose sign, but did not shift it. So this one would not work with a sign if you don't shift it left or right, because your y-intercept there is at a maximum point, and cosine has its y-intercept at a maximum point. So cosine is going to be easier to do for this one because you do not have to shift it left or right. And then I see several ones at the beginning. Do you have to put a 1 there? You do not, but you can. As far as like multiple choice problems, you're probably not going to see the 1 written there, but if it helps you to put that 1 there, it's mathematically correct, so it's fine to do. You can put the 1 there or not. It doesn't matter. So amplitude is 1. That looks good. We do not have, nobody added anything to the end because this has not been shifted up or down, so that looks good. But the problem, same issue we were having on the first one that we did before we knew much about periods, is the period on this one, right? Because the period did change on this one. The other ones we've looked at so far did not have a change for their period. So first, let's talk about what the period of this graph is. So what is the period for this graph? Pi. Because if we look at, I like to start from the y-intercept where x equals 0 because it just makes it easier to count. So right here I'm at a maximum point, and I'm going to trace my graph until I get back up to that maximum point, and then after that point, after that time, I start to repeat myself, right? I'm doing the same thing I was doing before. So for this graph, that distance is pi, so our period is pi. So I see that, let's see, wait. I see that Jaime there just put the pi there with the x. Usually I see more people doing that, and I do have some others that have done some different things that are not correct. But whatever the period is does not go next to your x. I think that is conclusively true in all cases. If it's not, there's like maybe just like one exception to that, but I think it's conclusively true. So whatever your period is does not go right there. So you would not put pi times x, because to find the period, remember we're thinking about our equation, y equals a cosine bx plus c plus d, right? To find the period of that graph, we would do 2 pi over this number right here, right? What does that number need to be for us to get pi? 2. It needs to be 2, right? So, the ones that have this are correct. Again, you can do parentheses or no parentheses. Either one. If you don't have parentheses, it is assumed that that term after it the whole thing would be in cosine. So anything multiplied together there would be inside of the parentheses. So either one is fine. And again, even down here, you can put the 1 if you want. You're probably not going to see the 1 written on a multiple choice question, but you can put it if you would like. Okay, so it should be a 2 instead of other things like 1/2 and whatnot. You probably, those of you that put a 1/2, we're probably thinking, well, it's half of 2 pi, so we need a half there. But what you got to remember is everything on the inside of everything on the inside is backwards. So you don't put a 1/2, you put a 2 because it's like 1 over that number that you put in there. So you do need a 2. Now, Abraham, don't change your sign stuff yet. I want to think about Abraham's real quick because sign is more complicated for this one, definitely. So now, if I look at Abraham's here, let me get rid of this. If I look at Abraham's, I need to have a period of 2 pi. I mean, not 2 pi. Period of pi. So for Abraham's, his period here would be 2 pi divided by that b value, which is the 2 in front. So that would give me pi. So the period is correct for this one. So it doesn't really matter whether you're using sine or cosine. Oh, it's that. Has he forgotten something, or is he not supposed to leave in the first place? Okay. All right. Okay. So 2 pi divided by 2 would give us pi. So the period is correct. The period, it does not matter whether you're dealing with sine or cosine, the period is going to be done the same. The phase shift here, your phase shift would be pi over 4 over 2. So dividing fractions is easy as pi. Flip the second and multiply. You're going to get pi over 8. So what this would do is it would take this graph right here. It would take sine graph. The sine graph would have a y-intercept at the midline, and then go maximum, midline, minimum, midline. So the original sine graph would look like this. How far would you need to move it over to get it to line up here? This is pi divided by 2. This is like half of pi. So this right here would be half of that, would be a quarter of pi. So we need to move it to the left pi over 4, which is probably what Abraham thought he was doing, right, by putting that plus pi over 4. But because you got to divide by that 2, it actually would need to be pi over 2 there instead, which we're going to look at a little bit more here in a minute. So it's close, but not quite for that one. So we will look at one where we're shifting there with a period change here in a second to get a little bit more clear on that. All right. Let me get rid of that scribble and go back over here. Student view. All right. Here's your next one. Okay, I'm going to tell you, no one is correct right now. Nobody in the whole class is right now. So try something else. I do see one correct now. Just one. So think about, like, if you're going from 0 to pi over 2, if you're taking half of that, it would be pi over 2 times 1/2. pi over 4. So the increments like in between would be increments of pi over 4. Which you will need to know for this. I see a few that are right now. I'm not going to tell you just yet. Not just yet. You'll eventually know. All right, let's look at it for this one. Okay. It really does not matter if you choose sine or cosine for this one because either one of those are going to have a phase shift. You're going to have to shift it left or right for this problem because your y-intercept for this one is not at the midline, nor is it at a maximum point. So it's not really easier necessarily to use one or the other. So you can choose sine or cosine. It really doesn't matter. So one thing that's probably throwing us off a little bit here might be the way that the x-axis is labeled because I have a lot of you that are using pi over 2. You're shifting the graph pi over 2 to the right or left, but we don't really actually need to shift the graph that far. So what's going to happen here is, first of all, we want to think about, let's think about the period of the graph to make sure we don't need to change that. And then let's think about what sine or cosine would look like if we just graphed it without shifting it. So first of all, let's check the period of this graph to see if it needs an adjustment. Because we do have several of you that, like Jaime here, has adjusted his period by putting that 2x right there. So I still, even if it's not a maximum or a minimum, I still like to start at 0. It's just easier to count if you do this. So right here is my point that my y-intercept. I'm going to go up, back down, and then it looks like right here is where I get back up to that same level that I was at before. And then after that, it's going to start to repeat, right? So, so that is a period of 2 pi. So since this has a period of 2 pi, that means that's our normal period for a sine or cosine function. You will not have a number in front of your x. So you don't have a b value, or if you do, it's a 1. So you do not have to put a number in front of that x there. The only thing you have to do to this graph is shift it left or right. So if we think about, I think I have more cosines than sines. So let's think about that. Cosine would have a excuse me, a maximum for its y-intercept. Then we would hit the midline, minimum, midline, maximum here. So this is what cosine looks like. So we need to shift this over just a little bit, right? We just need this maximum right here to go to the right a little bit to line up with that maximum of the actual graph we're looking for. So we need to figure out what in the world this is halfway between 0 and pi over 2. This would be easy if it wasn't pi's, right? If it was 4, you would know that that would be 2. If it was 8, you would know it would be 4. If it was 10, you would put 5, right? It'd be easier without that. But it's just half of the distance from 0 to pi over 2. So half of pi over 2 is pi over 4. Right, so this distance right here is pi over 4. So for cosine, what you want to do is shift to the right pi over 4. So that is going to be this answer right here. F of x equals cosine of x minus pi over 4. Oh, yay. Yes, let them in if they've got it. They're really small, though. They are very small. I got 2 of them, though, so I don't feel too good. Thank you. All right. So, what happens for the phase shift is you have to take this number right here and divide it by the number in front of your x. But there's nothing there this time, so it is actually just the number that you're shifting. If you have a period change, so like if the period of this was pi and we had a number there, it would make it more complicated, which we're going to see towards the end of this. But for this one, because the period has not changed, you can just put plus or minus the amount that you're actually going. They're a little tricky. Oh, it's not by 2 every time. It was 2 on the last one because we had a period change. So it depends on what number is there in front of your x. So if you have a 2 there, you're going to divide by that 2. But if you had a 7 there, you'd have to divide by 7. Okay? All right, so this is correct if you use cosine. Let's see about sine. Okay? The graph of sine, it has a y-intercept at the midline. And then it goes to a maximum, back to the midline, minimum, back to the midline. It looks like this. So, you would need to move this point over here so it lined up and slid everything the opposite direction. Still pi over 4 though, right? So if you did sine, you would need y equals sine of x plus pi over 4. There. Let me really complicate things. There are technically an infinite amount of answers that you can get for this. Because, do I have to shift this one to the left? I could shift it all the way to the right to where it hits over here, right? I could shift it all the way to the right. So instead of going pi over 4 to the left, which is easier, I generally try to go always the shortest distance because that's just easier to do. It would still be correct if I did y equals sine of x minus, and then that would be, oh gracious, this is one other reason why I try to avoid this, right? So if we, these increments right here, that'd be pi over 4. So this would be 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4. So 7 pi over 4. That would also be correct. Now, that would not necessarily be the easiest one to get. It would also be correct if we added 2 pi to that, or subtracted 2 pi to that, and used an even bigger number, right? Or 4 pi, or 8 pi. Like, there are infinite answers for this. It's just it would be odd for you to use one of those. And most of the time, they're going to be multiple choice so that you don't have to decide whether to move right or left. You just have to decide which one is correct. We okay here? All right. All right, let's see. Okay, so I had to do this a little bit differently because it would not let me put information and a graph that you could type in on the same slide. So I'm going to leave this up on the screen. I want you to graph an equation for me that has all of these characteristics. Okay, so amplitude is 3, period is pi over 2, midline is 0, and there is no phase shift. Okay, so you will go to the next slide where you can actually type in for a graph. I'm going to freeze mine here so that it will stay up on the screen. And then on this next slide, you can actually type in your amounts there. And it did say this one I'm telling you a sine function. So I'm telling you to use sine. Because you could use sine or cosine, but they'll look different. So, a little crunchy. I would have taken them out earlier. But still full of fat and sugar, so delicious. Alright, I'm going to go ahead and look at these. So don't change it just yet. I particularly want to see what Jaime did here, because I think I know I did. Jaime put the period in. Do we ever take the period and just put it into the equation? It will not work. Particularly, does Jaime have a variable? No. So, if you don't put a variable, sine of pi over 2 on the unit circle is 1, and so this is just like 3 times 1, so it's just graphing y equals 3. It's not even graphing a sine function. I could go over here and put an x with it. It's still not going to be right, because you can see like the period for this graph is right here, which is not pi over 2. So it still would not be right if it had that. But if you don't put the variable, it's just going to graph a straight line because it must have a variable there. All right. Okay. So let's see. I think one of these over here, these three all look the same. Let's see how they're doing. Okay, so 3, amplitude of 3, we've got that. That's the easier part of this, right? And they put a 4x, and let's see if that got them the period that we want here. You go up, down, and then back up pi over 2. This is the correct period. All right, so the what we need to think of for this, and so for the period, you always need to be doing 2 pi divided by b, right? And y equals a sine bx plus c plus d. So we're talking about this number right here in front of the x. So to get that to equal pi over 2, you have to put a 4 right here. A lot of times, particularly if you have a strange period that's like, let's say it was like 3 pi over 7, something really weird. What you can do for this is you can set up an equation. 2 pi divided by b is supposed to give you your period. They told you that that period was going to be pi over 2, so you can set up this equation. Which, on this one, you can probably just look at and tell b needs to be 4 for that to happen. Or you can solve it. You can solve it by cross-multiplying. So b times pi would equal 4 pi. And then you would divide off that pi, which would just cancel on both sides. And so b would equal 4. So that's the number that you need there. Okay. Questions on that? So if you take your formula for period, 2 pi over b, and set it equal to the period that it's giving you, then you can solve that to find what the b needs to be in that case. All right. Let's move on because we're running out of time. Okay, so that one, 3 sine of 4x is correct. So if you want to change yours to that, you may. We're going to go to the next slide here. This one, amplitude, period, midline, phase shift of pi over 4 to the right. And this one asks you to do a cosine function. Alright, let's see. I'm moving quick because alright, I'm going to show this one. It's not right, but I'm going to show it. Amplitude 2. Okay. This one's close. This one is wrong. Sarah's got this one wrong. Why? What did she do wrong? The period is supposed to be 2 pi. We do not put the period into the equation, right? So this right here is the problem with this one. This one does have an amplitude of 2. It does have a midline at 6. So that 2 out front and the 6 on the back is good. It actually has a weird phase shift because of the 2 pi that she put there. But the standard period for sine and cosine is 2 pi. So you actually don't need anything there at all. Because if you don't put anything there, the period will just be 2 pi. Let's see about this one. Okay, Ada has one that I think looks beautiful. Okay. Oh, wait, no. This one's wrong. What's wrong about it? Amplitude is 3. It should have been 2. That was probably just an oversight there. Let's go see. Let's see about Erica. Okay, Erica. I think this one looks beautiful. It did say to the right, didn't it? So amplitude is 2. Midline is 6. That looks great. The period of this is 2 pi. If you look here, you're going to hit back at about that same level at 2 pi. Cosine normally, here I'm going to graph 2 cosine x plus 6. Normally cosine would look like this. You've got to shift it pi over 4 to the right to get this, so this one looks good. There was not a phase shift and a period change on this one. We did not get to the last couple on this, which is where we were going to see those ones where we end up with like a phase shift and a period change. So try the other one, try the one on Desmos Classroom. That is, how do I get back just to the class? I want to go. No. How do I even get back to it? Anyway, if you go to student.desmos.com, there is another one that's called Practice. Do the best you can. You may have some trouble when you run into the period change and the phase shift. We will talk about those in class, okay? But try something on every problem. The one that says practice will be your homework. So do it. There may be a couple you're not too comfortable with. Try something. Like you might not get the period and the phase shift right, but at least get the amplitude, midline, that sort of stuff. So put something in, and then we'll talk about them because we didn't quite get done.